today we're going to be talking about section 4.4, and we're going to be talking about parallel and perpendicular lines. So parallel lines, obviously we should know what that is, but just in case, those are lines that do not intersect. And lines that are non-vertical, so basically lines that don't run straight up and down, parallel lines, they have the same slope. Now, you can write an equation of a line that's parallel to a given line if you know a point, and then you know that equation, because that's where you can get the slope. So we're going to be comparing lines together and figuring out what the slope is and using that to write an equation of a different line. So let's jump into it here. We're looking at a line that passes through the point -3, 5 and is parallel to the graph of y equals 2x minus 4. So again, just to kind of give you a picture of what's going on, we're looking at the point -3, 5, and here's our point that's on our line. The other line that it's running parallel to, so never touching, is y equals 2x minus 4. If I was going to graph y equals 2x minus 4, I would be down here at -4. I'd go up 2 over 1. This would be what my line looks like. We are trying to figure out what's the equation of this line that passes through the point they gave us right here. Okay, we know this one is the y equals 2x minus 4. We're trying to figure out what this one is over here at the top. Okay, so that's kind of what's happening here. If we're going to do this, we first have to figure out what's the slope of the given line, and we're going to use that to find our slope. If the lines are parallel, that means they have the same slope. So looking at the equation they gave us, y equals 2x minus 4, I'm going to identify what the slope is, and I'm going to use that to figure out what the slope of my line also is. So we're going to say that m is equal to 2. Now, if you remember the point slope form that we talked about yesterday, this is a great time to use that and then solve it for slope-intercept form like we did at the end of the notes. And I said yesterday, but I meant in the last section. So when we're looking at point slope form, y minus y1 equals m times x minus x1, this point that our line is passing through is like our x1 and our y1. We know that m is 2, so we have 3 numbers that we can sub in here. And then we're going to use that to solve for the slope-intercept form, because if we look at the directions, that's what they were asking me to do right here. Okay, we want to make sure we answer it in the right format. So we're going to start with y minus y1. So y minus the y value from my point, which is 5, is equal to m, which is the slope that we found, so 2. And then x minus the x value from our ordered pair, which was -3. So again, changing over any double negatives that we have. So we're going to make that x plus 3 in parentheses. Right now, this is in point slope form. We need it to be in slope-intercept form, like the directions asked. So our 2 steps that we have to do are distribute a property and move this -5 to the other side. So y minus 5, 2 times x is 2x, 2 times 3 is 6. And then my last step would be to add 5 to both sides. So my final equation is going to be 2x plus 11. So if I graph this equation, 2x plus 11, okay, that's pretty much saying my slope is 2, and it's crossing up here somewhere on my axis, which would have to be at positive 11. Positive 11. There we go. So that's kind of what's happening here. You're trying to find what this other equation is making. Okay? So again, if you're solving that, use the point slope form, start out, and then you'll get to your slope-intercept form after that. Okay, on this one, they're telling me again, the line is passing through 4, -1, and it's parallel to the line y equals 1/4 x plus 7. So it's important to note that it's parallel because that means they have the same slope. If their slope is 1/4, I can say our slope is also 1/4, and then I can go from there. Okay, my x1 and my y1 values, those are going to come from my ordered pair here. That's going to be the 4 and the -1. All of those things are going to get plugged into my point slope form, which again looks like this. So whenever I sub in my numbers, I have y minus the y value here, which was -1, is equal to my slope of 1/4, then x minus the x value from my ordered pair, which is 4. We can change our double negative on the left side to y plus 1, then 1/4 times x minus 4. Okay, we're changing this into slope, we're going to write an equation that is in point slope form this time. Oops, sorry about that. So if they're asking for the answer in point slope form, there's nothing else that I need to do here. Okay, this right here is point slope form. I don't need to continue on doing distributive property and things like that because they are not asking for a different format. If they want it in point slope form, we can leave it just like this. That's how our equation is going to look. So make sure you're reading. Okay, don't make the same mistake that I almost did. Point slope form versus the last one was asking for slope intercept form. It's always going to be very specific about what it's asking for, so make sure you read those directions. Okay. Now we're going to talk more about perpendicular lines. Those are lines that intersect and they form right angles, so think like a four-way stop. The slopes of non-vertical perpendicular lines are opposites and reciprocals of each other. Okay, so it's really important to know what that means. Opposite means like opposite signs, one's positive and one's negative. Okay, reciprocals means you take the fraction and you flip it on top of itself. So for example, if the slope of one of our lines was 2/3, the slope of a perpendicular line is a negative 3/2. Okay, so again, the 2/3 was positive, negative 3/2 is obviously negative. Okay, taking 2/3 and flipping that would make it 3/2. That's the reciprocal. So, first thing that we're going to look at here is we are going to have to find the equation, the slope of the equation that they give us, and then apply the information that's given to us so we can figure out what the slope is. So they're telling us that the point, our line passes through the point -4, 6, and it's perpendicular to the graph of 2x plus 3y equals 12. Now the first thing that's wrong with this is that this equation right here does not come out and tell me what m is because it's not solved for y equals mx plus b. I don't know the slope right off the bat. So I'm going to put it in slope intercept form first. So I'm going to take my 2x plus 3y equals 12. I'm going to subtract my 2x and put it on the other side. That's going to leave me with 3y equals negative 2x plus 12. And then I'm going to divide by 3. So the final equation of my line here is y equals negative 2/3 x plus 4. I had to do that so I could figure out what is the slope of their line, which is negative 2/3. Okay. So this time, whenever you're finding the slope, since they're telling you it's perpendicular, okay, their slope was negative 2/3. Okay. Ours has to be the opposite and the reciprocal of that, so ours is going to be a positive, and I'm going to take 2/3 and flip it over and make it 3/2. This is the slope that you need to make sure you plug in for m when you do point slope form. So now we can finally use point slope form, use the point that was given to you way back here, -4, 6, and the slope that we just found of 3/2. So when I sub those in, y minus y1, so y minus 6, that comes from the ordered pair. M is 3/2. Again, make sure that we're using our slope. We don't want to use their slope. We only needed that for a second. And then x minus the x point from our coordinates, so -4. Okay, take care of any double negatives that you have. That's going to become x plus 4. Double check the directions and make sure you're answering it in the right format. Okay, this one's asking for slope intercept form, so we are going to continue solving here. Okay, start with distributive property. 3/2 times x would be 3/2 x. 3/2 times 4, that would become 12/2, which is going to be 6. Okay, the last step here is get rid of the -6, so we're going to plus 6. So we've got y is equal to 3/2x and plus 12. If I graph this line along with the line that they gave us in the beginning, those two lines would be perpendicular to each other. They would form right angles whenever they cross. Okay. So we'll do one more like that. If this is too fast, you can always go back and watch it again if you need to pick up one of those steps. So on this one, they're passing through the point 4, 7, and it's perpendicular to the graph of y equals 2/3 x minus 1. Okay, whenever it's like this, this is a little bit easier on us. because right away I can tell what the slope is. Okay, their slope is 2/3. Okay, so we need to take that and do the opposite reciprocal. So ours is going to have to be a negative. Theirs was 2/3. We're going to flip that over. We are going to be using 3/2. Once I do that, I'm done with this slope. I'm done with this entire equation. I'm not using anything else. I have the information that I need there. Okay, that is our m value. Okay, here's our x1 and our y1. So we're going to start with subbing those in. So y minus y1, m times x minus x1. That's the point slope form we're using. Okay, our equation is asking, or our question is asking for slope-intercept form, so we need to make sure we solve this completely at the end. So y minus y1 would be 7 from our ordered pair. M, make sure we're using our slope, so negative 3/2. And then x minus the x coordinate, which is 4. We're going to start with distributive property to solve this all the way. So it'd be negative 3/2 x. The negative 3/2 times a negative 4, that's going to become a positive. 3/2 times 4 is going to be 12/2, which is going to be 6. And finish that by adding 7 to both sides. That's going to make our final answer. Y is equal to negative 3/2x plus 13. Okay, so that's how we're going to go about making those perpendicular graphs. Now the last thing we're going to look at is we are going to determine if the lines are parallel, perpendicular, or neither. Okay, whenever we do these, we're always going to compare the slopes. Okay, if they're parallel, they're going to be equal to each other. They're going to be the exact same. Okay, so parallel lines always have the same slope. If they are perpendicular to each other, remember they have to have those two things. They have to be opposite signs and reciprocals. Okay. The neither category would be just two random numbers that don't fall into the parallel or the perpendicular category. So the first one that we're going to look at here, 6x minus 2y equals negative 2. I'm going to change this into point slope form so that I can figure out what, or I'm sorry, slope intercept form, so I can figure out what m is. So I'm going to start by subtracting 6x. We're going to have negative 2y equals negative 6x and a minus 2. We're going to divide by negative 2 to get y by itself. We have y is equal to, this reduces negative 6 over negative 2 to positive 3. And negative 2 over negative 2 is a positive 1. Okay. The slope we are looking at for this line is 3, and that's the only thing that we are looking at. And we're going to compare it to our second line, y equals 3x minus 4. Now this one doesn't require any solving here. Okay, we just need to know what is the slope. And if you look here, they tell you right away that the slope is 3. So if both of the slopes are 3, okay, we're looking at these lines being parallel to each other because they are the exact same. So that's how you would compare those. If you have like a positive 3 and a negative 3, okay, that's not enough to be perpendicular. That would just be in the neither category. So this is a little bit of a harder section, so you need to go back and rewatch any of this. That might be helpful. There's 10 questions that you're going to do. Okay, as always, check those odds in the back so that you know which ones you're supposed to be taking care of, and you make sure that you're doing those right. And then there are a few that are even, so you might need to ask for some help on those if you need it. Okay. Have a good day.